Have you ever looked at an exam question and wondered what really separates a good answer from a great one? Well, today, we're going to pull back the curtain. We're taking a real GCSE physics question and breaking it down piece by piece using the official mark scheme. This way, you can see exactly how and where every single mark is earned. All right, let's get into it.
So, here's our plan. First, we'll introduce our challenge, which is question 5. Then we're just going to work our way through each part, a definition, a couple of calculations, and a conceptual explanation. And to finish, we'll boil it all down into some key takeaways you can use in your own exams.
Okay, so this is it. Question 5 from a recent higher tier paper. This is the perfect kind of question to look at because it tests a whole range of skills. Everything from just remembering a definition to doing multi-step calculations. By breaking it down with the mark scheme, we're not just finding the right answers, we're learning the strategy to get every last mark.
Right, let's kick things off with the first part, 05.1. Now, on the surface, it looks like a simple one-mark definition. But trust me, these are exactly the kinds of questions where every single word matters. Get a bit fuzzy with your phrasing, and that one mark can just disappear.
Here's the question itself. What is meant by center of mass? So before I show you the answer, just take a second. How would you put it into words? What are the key ideas, the key phrases you think an examiner is scanning for?
And here's what's so interesting. This shows the two completely acceptable answers, taken word for word right from the mark scheme. You could say the point from which weight may be considered to act, or you could say the point where the mass appears to be concentrated. Either one gets you the mark. This is so important. It shows you don't need to memorize one single perfect sentence. You just need to understand the concept well enough to explain it correctly.
Okay, let's move on and see how the challenge ramps up a bit. We're now looking at a 3-mark calculation. And remember, for a question like this, the final number you write down is only part of the story. The marks are given for your method, for your steps. Showing you're working isn't just a good habit, it's absolutely essential. So the question gives us this picture of 5 tomatoes on a scale. Our first job, always, is to be a bit of a detective and just pull out the data. The scale clearly says 425 grams for all 5 tomatoes. That's our starting point. And this lays out the path to those 3 marks perfectly. Look at this. First, you get 1 mark just for converting 425 grams into the standard unit, 0.425 kilograms. Easy mark. Your second mark comes from the next logical step, finding the average mass of 1 tomato, which is 0.085 kilograms. And finally, that third mark is for plugging this mass into the weight equation and getting the final answer of 0.833 newtons. 3 clear steps, 3 guaranteed marks.
All right, let's tackle our second calculation, part 05.3. This one tests a different bit of physics, all about springs and making sure you can apply that key formula correctly.
Now the question gives us everything we need right here. We've got a force of 6.0 newtons and a compression of 0.015 meters. And a quick tip, don't let the word compression throw you. In this context, it's basically the same as extension. It's the E in our equation. Our job is to find K, the spring constant.
And just like before, you can see the crystal clear path to getting full marks. You get 1 mark for correctly putting the numbers into the F equals K times the equation. You get a second mark for rearranging it correctly to find K, and that final mark is for the right answer, which is 400, and don't forget the units, newtons per meter. It's a foolproof system when you show your work.
For the last part of this question, the focus shifts again. We're moving away from the numbers and back to explaining the science. It asks why a spring is a good choice for a weighing machine. This is where you prove you actually get the physics behind it all.
And once again, the mark scheme gives us 2 totally separate, equally correct ways to get the marks. On the left, you could talk about elasticity, how the spring bounces back to its original shape. That gets you the point. Or, as you see on the right, you could talk about proportionality, the idea that the squash is directly proportional to the force, which is what gives you a nice, reliable, linear scale. The big takeaway here? There's often more than one right way to explain the science.
So, we've pulled apart every single piece of question 5. But what are the big lessons here? What are the strategies we can learn from this one example that you can apply to any exam question you face? This slide really says it all. First, know your definitions, but focus on understanding the concept, not just memorizing one set of words. Second, always show you're working. It's your safety net. Third, watch those units. Always convert to standard units like kilograms before you start calculating.
Fourth, read the full question carefully and pull out all the numbers. And finally, remember that little word "or" in the mark scheme is your best friend. It means there's more than one way to get to the right answer.
And that brings us to the final, and probably the most important point. Today, we used a mark scheme not just to check answers, but to get inside the mind of the examiner, to see what they're really looking for. So the real question to leave you with is this. How can you take this method and use mark schemes to superpower your own revision, turning every practice paper you do into a complete masterclass? Think about that. Thanks for watching.